A box with a square base and open top must have a volume of 37,044 cubic centimeters. We wish to find the dimensions of the box that minimize the amount of material used. Answers must be correct to at least three decimals. Okay, so we have this box. Notice it says it's a square base, open top. You can see the top is open and the base is square. So what that means is, let's see if I can do this right there, right there. Bring this line down there. You just see those back lines back there. Anyway, so the base is square. So let's and we're trying to minimize the amount of material. Okay, so they want a surface area formula. All right, so what is the surface area? Well, the area there, I'll just say surface area. So that's all the material. Surface area, well, you're going to have the bottom of the box right here. And what's that? That's going to be x squared, right? Just one side times the other. And then you're going to have, um, let's say the left and the right. This is the left. So what's the area of that? Well, this this is x because this is the same as this, and this is y. So it's x by y. So it's a rectangle. It's by the same thing here, right? This is going to be y. So this right side is also x by y plus. And then we have the front and the back. Kind of room here. Front and the back. So we have the front of the box. And what's that? Well, that's x by y. And the back of the box, same thing, x by y. There we go. So the surface area, I'll just say the area formula, is x squared plus 1, 2, 3, 4 xy, right? These just add up like terms, 1, 2, 3, 4 xy. Now, we're not done because they said in terms of only x. So they don't want this y here. We got to get rid of that y somehow. Well, how in the world are we going to do that? Well, we have another fact we haven't used, the volume. The volume. Now, what's the volume of a box? It's length times width times height. This is width, length, this is height. You could change them around. And they're telling us the volume is equal to 37,044 cubic centimeters. So that would be the length and width, both x, and the height is y, right? Height is y, is 37,044. So that means I can, you see what I can do now? I can solve for y divided by x squared on both sides. Boom, boom. So therefore y is equal to 37,044 over x squared. And now I can bring this area formula, or I could just plug this in right here. This is y. I can plug that in right there for y. So then the area formula will equal x squared plus 4x times 37,044 over x squared. One other thing, you can cancel this and one of these, right? So that's how they got that. There it is. There's the area formula for that box in terms of x only. And then this is just the setup. And then so there'll be another problem. We'll go on and we'll say, okay, now that we have that equation, let's find the box that has the minimal surface area, right? That's what we really want to do. Is minimize. That's what companies, this is expensive material, or even if a UPS or FedEx, one of those companies that ships a lot of stuff, they want to make the box use the least material possible to hold the volume they need, 37,044 cubic centimeters, making it out of the least material possible. So we're going to minimize this surface area formula, right? This one that only has X, take the derivative and set it equal to 0 and find the x value that will make, and the y, that will make the box of minimal surface area, least material, to hold the volume we need. That'll be another problem. And so there we go.